Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the Find the Town Judge problem. It's a quick update first though, hopefully there's a bit less echo in here. I've put up some sound absorbing panels and hopefully also I have a stable internet connection, finally. Okay, so that'll mean all the videos now are back on regular schedule. Right, finding the town judge. In a town, there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. And everybody, except for the town judge, trusts the town judge. There is exactly one person that satisfies properties 1 and 2. You are given an array trust, where trust I is equal to AIBI, represents that person AI trusts person BI. Return the label of the town judge if the town judge exists and can be identified, or return -1 otherwise. Interesting, it's a little logic puzzle. So here, 1 trusts 2. So 2 must be the judge because everyone except for the town judge trusts the town judge. So there's 2 people. The town judge trusts nobody. So 2 doesn't trust anybody. And everybody except for number 2 trusts 2. Okay. N equals 3. 1 trusts 3 and 2 trusts 3. So we would expect then that 3 is going to be the town judge, and sure enough, 3 trusts nobody, and everyone else trusts 3, so therefore we return 3. The judge is number 3. Similar case here, 1 trusts 3, 2 trusts 3, so everyone trusts 3, but the judge should trust no one. But here, the judge trusts number 1, so he's not the judge, so we can't identify a judge. Return -1. Ha! This is a neat little idea. So the people is 0. Hang on, no, it's 1 and if there's 2 people, it's 1 and 2. Range 1 m plus 1. So let's decide. Well, there's 2 things we need to know. Who trusts no one? Well, if you trust no one, that means you never occur in position 0 in our trust array. So this is people minus the set of people that occur in T0 for T in trust. And then trusted by all is how do we want to say this? What we want is T1 for T in trust. What I want to do is I want to do iter tools. Oh, no, it's collections, sorry. Because what I want to do is I kind of want to count how many people trust each person. And then it's going to be the set T for T. Let's make this. What order are these coming? TC dot items if C is equal to n minus 1. Oops. How do I want to do this? So t, let's print these sets out and just see what we're doing. We'll return -1 always. So let's see what we know so far. Print people, print trusts no one, print trusted by all. These are just literal translations, by the way, using the right API, of the statements we were given. The town judge trusts nobody. So someone who trusts nobody is someone who doesn't trust. They're not in this trust array. The people, obviously, is just a set of people 1 to n. And trusted by all is someone that is trusted by exactly n-1 people, because they are not themselves. They don't trust themselves, obviously. So we see the people is 1, 2. There is exactly 1 person who trusts no one, and there is exactly 1 person who is trusted by all. That's good. That's going to be the person we want. Here we see the same thing, 3 and 3. And here we have the empty set and 3. So we're going to struggle with this one. The one thing I'm unsure about is if there's 2 people that everyone trusts. I don't know. But anyway, once we've got to this point, what we want is we want trusts no one and trusted by all. These are our possible judges. It's the one who trusts no one and is trusted by all. This is our, so if they satisfy both of these properties, and this is exactly 1, I think I can do that. And then if we fail, return -1. There's one thing I'm slightly unsure about in this definition. It's do these 2 sets both have to be singleton and have the same person in them? Or is it enough that there be 1 person that overlaps? It be precisely 1 person that is in both sets. And it may not be possible to actually construct a set where that is true. But I don't know. Anyway, let's try this. Excellent. Let's do a quick little complexity analysis of this. So this is going to take order n time. This is going to take, well, t time, roughly. So that takes t time to do that. This is n plus t, I think. This one here is order t time again. So this is order t time. This is going to be, this one is t plus n, this one is t. So I think this is t plus n again. This is order 1. So it's going to be order t plus n. So where n is the number of people and t is the number of trust relationships we have, which is up to n squared. Because if everyone trusts everyone, that's essentially your handshaking lemma. I'd recommend you look that up. But basically the idea is that the number of ways that everyone can trust everyone is, in this case, exactly n squared, I think, or n minus 1 squared. This one, there's a little quirk on this one. The handshaking lemma is defined for undirected relationships, whereas this is a directed relationship. Just because A trusts B doesn't mean B trusts A. Anyway, let's submit it. That's enough rambling for this problem. Wrong answer. Aha. Right. This is a bit of an edge case, isn't it? If the judge is there, yeah. People minus empty, that's empty. The problem is this one here, trusted by all. We're going to end up with an empty set. So if n is equal to 1, and trust is empty, return 1. Does trust need to be empty? I guess it must be by definition. Do we know A is never... Yeah, A is never B. And A and B must be between 1 and... Okay, so that check is redundant. That's just invalid in the specification of the problem. But if there is exactly one person, they're the judge. They must be the judge, because there's nobody for them to trust. And everyone else, who is no one, trusts them. So sort of a degenerate case. A single person is the town judge. There we go. Excellent. So slight quirk at the end there that we should have thought about with our edge case, but not too bad. And the nice thing about this solution is it is very direct. There's nothing clever in it. It's just the use of sets and logic. Who are the people? Who are the people that trust no one? Who are the people that are trusted by all? Who's in both of those sets? And if there's exactly one person, make it that. They are the judge. It is a direct translation of the problem statement. I love code like that. And the reason I love code like that is basically because it's so much easier to maintain in the long run. If this matches my problem specification, as soon as the problem specification changes, the code needs to change. And I can just keep that tight loop going the whole time. Anyway, do let me know if you went about it differently. Did you have something much more clever, something much more algorithmic, or did you just hammer away at this with lots of for loops? Because there are lots of for loops in here, but they're hidden inside comprehensions and inside set operations. So this looks quite short, but in languages like C, for example, this would be quite verbose. Do let me know how you got on. Do remember to like, comment, subscribe, all of that good stuff. And I will this week, now that I've got internet connection back, see you next time. Bye.